Okay, today we are going to be looking at using inverse functions. We're going to be finding the equation for an inverse relation, verifying functions are inverses by using composition, and determining if a function has an inverse by using the horizontal line test. So first let's talk about what an inverse relation is. And a relation is basically any set of ordered pairs, not necessarily a function, but okay, so an inverse relation interchanges the x and y values of the original relation, okay? So if necessary, here are the steps. If necessary, what you're going to do, we all know that f of x is just the same as y, okay? So then you'll switch the variables x and y, and then you are going to isolate the new y. And what we'll be doing is we'll be writing like this. It looks like f to the negative 1, but let me tell you that this f to the negative 1, that's bad, okay? So that's not what this means. This is actually inverse notation. And when we ask you to write, be sure to write your answer using inverse notation. This is what we want you to write. And essentially, this is read it's read as f inverse of x. So when we see this notation, it's really read as f inverse of x. So not f to the negative 1, and don't even say, oh, the f to the negative 1 thing. It's read as f inverse, okay? So we're going to be writing it in inverse notation. So let's practice that first learning target. I can find the equation for the inverse relation. So the first says that y equals 7x minus 4. So we've already got x and y as our variables. So now we'll switch the variables x and y. So we'll say that x equals 7y minus 4. Next, step 3 is we'll isolate our new y. Well, how would we get y by itself? Well, we could start by adding 4. So I get that x plus 4 equals 7y. And then I could divide by 7. And I get that y equals x plus 4 over 7. So y is isolated. So then step 4 is just use the inverse notation. So that means that f inverse of x equals x plus 4 over 7. And that's essentially it. You could, by the way, distribute this 7 to each of these and write it as like 1/7 x plus 4/7, or x over 7 plus 4/7. Either one is okay, all right? But this is a little less work because you have one less step. Let's try another one in B. F of x equals negative 5x plus 2. So again, we replace f of x. We know that that's really like a y. So this is like y equals negative 5x plus 2. So step 2, we'll switch the variables x and y. So we'll end up with x equals negative 5y plus 2. And now we'll isolate our new y. So to isolate y, we would subtract 2. So I get x minus 2 equals negative 5y. And then I'll divide by negative 5. And I get that y equals x minus 2 over negative 5. So we'll just replace y with this f inverse of x notation. And so we can say that f inverse of x is x minus 2 over negative 5. You also could move the negative to the numerator and write it as negative x plus 2 over 5, or you could distribute the 5 to each of the terms and get negative 1/5 x plus 2/5. These are all equivalent forms of that inverse function. All right, let's do the same thing in C. Here we have a nonlinear function. We can still find the inverse of nonlinear functions. Well, again, we know that f of x is our output y. So now let's switch our input and output. So we have x equals 4y cubed minus 5. Now let's isolate the y. So we'll add 5. So I get x plus 5 equals 4y cubed. You would not take the cube root yet. First, we want to get rid of the 4, guys. So we would divide by 4. And now that we've isolated the power, now we can take the cube root of both sides. So essentially, we have that y equals the cube root of x plus 5 over 4. And I know that at some point in your mathematical lives, you may be asked to rationalize that, but for our purposes, it's fine for you to leave your answer like this. Okay, just don't even worry about rationalizing the denominator at this point, okay? So that's it. So that's the first learning target. I can find the equation for the inverse relation, okay? The second thing we're going to do is just verify functions are inverses by using composition. And so here's how that works. Functions f and g are inverse functions of each other, provided that f of g of x equals x, and that g of f of x equals x, okay? And then for our things, they're denoting g by f inverse, okay? So when it tells you to verify that functions are inverses, that directive implies to use composition. And you're going to just show that regardless of the order that you compose the functions, we get x. So let's try that in example 2a, where we have these two linear functions, and we want to verify that these are inverses. So the first thing we want to do is deal with f of g of x. So in this case, f of f inverse of x. So we're going to compose these two functions. Now remember, this is the inside function, so that means that we're taking f of 1/7 x plus 4/7. Now again, based on what we talked about with composition, that means that this is going to be substituted in for the x in f of x. Well, f of x was 7 times something minus 4. So that something is the other function, which is 1/7 x plus 4/7. So now let's take, let's distribute. So this gives me 1x. 7 times 4/7 just gives me 4. And then I bring down the minus 4. And then I get that I get x. So f of f inverse of x gives me x. But notice that it has to be both ways, because we've looked before at how the order of composition, like composition is not commutative. So now let's try f inverse of f of x and make sure that we get it. So that means I'm taking f inverse of 7x minus 4. So again, based on what we talked about with composition, that means we're taking the rule for f inverse, which is 1/7 times something plus 4/7, and putting the f of x in. So I'll put in the 7x minus 4, and now let's just simplify. 1/7 times 7x is x. 1/7 times negative 4 is negative 4/7. And then I have this plus 4/7. Notice that these cancel, and I end up with x. And so we've verified that they are inverses by showing that f of f inverse of x and f inverse of f of x give us x. So it's really this whole thing that I would happy cloud, because that whole thing is the verification that they're inverses. Okay? Please label which one is f inverse of x and which one is f inverse of f of x. Okay? Please label and then show the work. Let's try the same thing in letter B. We can do this with nonlinear functions. So again, we'll start with f of f inverse of x. So that means we're going to take f of the cube root of x plus 7. And the rule for f of x is that we're going to cube something and then subtract 7. And so here we're cubing the cube root of x plus 7. Well, notice that we're cubing a cube root. So those are inverse operations. Those cancel. And I end up with x plus 7. And then I'll bring down this minus 7. And that gives me x. So now I need to find f inverse of f of x. So that means that I want f inverse of x cubed minus 7. So the rule for f inverse is I'm going to take the cube root of something and add 7. That's the rule for f inverse. I'm going to take the cube root of something plus 7. So that something is the x cubed minus 7. Now make sure that you follow appropriate order of operations. We cannot distribute that cube through the cube root over the subtraction and addition. But notice I can combine like terms on the inside, and I'm just taking the cube root of x cubed. And notice that the cube root of x cubed is x. And so both f of f inverse of x and f inverse of f of x gave me x. So I have verified that these functions are inverses. And anytime you see verify, that does not mean to find an equation. When you're given two equations and asked to verify, that means that you should use composition. Okay? All right, a little fun fact is that the graph of a function's inverse, because we're switching x and y, is just a reflection of the original function in the line y equals x. So here's a table and a graph of f of x equals 3x minus 1. Let's say that you wanted to graph the inverse. To graph the inverse, we would just switch the x and the y coordinates. So what we would do is these f of x's turn into x's, and the x's turn into y's. And these ordered pairs would give us the inverse. So let's plot those points and see what it would look like. So for the inverse, one of my ordered pairs would be negative 7, negative 2. So I could go to negative 7, negative 2, and plot a point. Then I would think about negative 4, negative 1. Then I would plot negative 1, 0. 2, 1, and then 5, 2. And so this would be the graph of my inverse, f inverse of x. And so just wanted to have that little fun fact. We used to do it with the kids. And so if you were to draw the line y equals x, I'll draw it here like as a dotted line. It's the one that has a slope of 1 that goes right through the origin. Do you see that if you folded the graph on y equals x, that it looks like they would pretty much match right up? So notice that there's that reflection in the line y equals x, okay? All right, so that's a little fun fact. All right, so the last learning target specifically says, I can determine if a function has an inverse by using the horizontal line test. What is the horizontal line test? Well, when we talk about the horizontal line test, we can say that the inverse of a function f is also a function if and only if any horizontal line intersects the graph of f exactly once. So remember the vertical line test, how if like a vertical line only intersects a relation once, it's a function. This is the same type of thing with the horizontal line test. But please note, this is a test we do on the original function to decide if the inverse is a function too. So the graphs that you see here are functions. These are functions that pass the vertical line test. But we want to know, if we were to find the inverse, would the inverse also be a function? So what we do to do that is the horizontal line test. So notice that if we take a horizontal line and we pass through it, at any point, it only hits once. So notice that it hits only once, and any horizontal line will intersect the graph exactly once. Okay, so if I had this line, only once. This horizontal line, only once. Okay, so that tells us that our inverse is a function. But let's look at this function. This function, here is an example of a horizontal line that intersects the graph twice. All we care about is that that's more than once. And so because that happened more than once, that means that our inverse is not a function. So again, these are functions, but we want to know, if we were to find the inverse, would the inverse be a function too? In this one it would be, because it passes the horizontal line test. But this the inverse of this function would not be a function because it passes through more than once. And we'll talk more about what we could do to rectify that tomorrow. But today we're just determining if the inverse of f is a function. Okay? And in this section of homework, you'll be able to review how to graph some of the different functions we've had. And so go ahead and look at your old notes if you forgot how to do those. Well, letter A, hopefully none of us forgot. F of x equals negative 2x minus 3. So let's graph that function by, remember we start by graphing the y-intercept, 0, negative 3. And a slope of negative 2 means we would move down 2 to the right 1. And then I can also go up and to the left to make more points. Okay. So I'll connect these points. And here's the graph of the function, f of x. So we don't have to find the inverse, but we want to know, if we did find it, is the inverse a function? Well, let's look at the horizontal line test. Does it pass? It does pass. So we would say yes, but I want you to have a thoughtful explanation so I know that you're not just guessing, that you know what's going on, okay? So what we're saying is that the inverse is a function because f of x passes the horizontal line test. Yes, I want you to write this whole sentence, okay? Notice there was no it in this sentence at all. We have to be very specific. The inverse is a function because f of x, the original function, passes the horizontal line test. Okay? Let's try letter B. Okay, so this is an absolute value function. Well, remember, these are V-shaped, and oftentimes we try to find the vertex. Our vertex is going to be 1, 2. So we'll make a point at 1, 2. And then to decide how it opens, we look at our A value. Our A value is 1, so that means that it will open up with a slope of positive and negative 1. So we'll start at the vertex and go up 1 over 1, to the right and to the left. to give it that V shape of the absolute value graph. And then we'll just connect these points. And then that's how we graph absolute value functions. So now that we've graphed f of x, which is a function, we want to see if the inverse is a function, and we do the horizontal line test. So let's try. Uh-oh, notice that we have a horizontal line that passes through more than once, actually on several occasions. So that means that the inverse is not a function. So we would say, no, the inverse is not a function because f of x does not pass the horizontal line test. Okay, again, notice I didn't use the word it in there at all. I was very specific and saying that we use f of x, we use the horizontal line test on f of x, and we're able to make a decision about the inverse being a function based on that. So no, the inverse is not a function because f of x does not pass the horizontal line test. Okay? So let's look at letter C. F of x equals x cubed plus 1. Well, here's a cubic function. So it's a polynomial function. It is just in standard form. So oftentimes what we do for that is we make a little table. And we used -2, -1, 0, 1, and 2. Since it wasn't in intercept form, in that factored form, we would just use -2, -1, 0, 1, and 2 as our values. And remember, we just substitute those in. So -2 cubed is -8, plus 1 is -7. -1 cubed is -1, plus 1 is 0. 0 cubed is 0, plus 1 is 1. 1 cubed is 1, plus 1 is 2. And 2 cubed is 8, plus 1 is 9. And so we could graph those and see how the graph looks. Up here. Oops. And so if I look at this function, I can see, if I graph, looks like this. And if I use the horizontal line test, I can see it looks good. It looks like it only passes once each time. So I can say, yes, that the inverse is a function because f of x passes the horizontal line test. And I understand it's writing. You're going to be okay, all right? We don't ask you to do a ton of writing in here, and so I think this sentence is not a stretch, okay? So that is it. Thank you for being patient with me being out, and you guys can get started on the homework. We'll do this next time we meet. Okay, have a great day.